I'm Charles Wilson, Staff Product Cybersecurity Architect at Torque Robotics. This presentation will cover an overview of threat modeling. This diagram shows the overall AVCDL training path. If you're taking this training, it's assumed that you've already completed the AVCDL overview training, and additionally, that you've completed the requirements taxonomy, security requirements, secure design principles, apply secure design, and threat prioritization plan training. This training will cover an overview of threat modeling. When thinking about cybersecurity, and especially when they hear terminology like threat modeling and penetration testing, most people, if they're not cybersecurity practitioners, tend to have this idea that cybersecurity is some black art done in a dark room by people with hoodies, and that it's impenetrable. In reality, cybersecurity at the product level is something more akin to an open kitchen where we can observe all the processes that are going on and look for areas where issues may arise that may result in harm. Threat modeling is one of these. We're going to be talking about how we look at the processes that exist and determine whether there are issues in those processes because of deficiencies in design. Let's review how the AVCDL addresses our two major concerns within cybersecurity, those being design deficiencies and implementation defects. The combination of processes addressing both design deficiencies and implementation defects yield the highest level of certainty that we will attain sufficient cybersecurity rigor for the product. It's within the processes addressing design deficiencies where we'll find threat modeling. You'll note that it has a dual in the verification phase where we perform a threat modeling review. This allows us to ensure that those deficiencies that we've identified in the design phase were in fact corrected in the verification phase. Here's the terminology as used within the context of the AVCDL. It's based on the threat model glossary proposed by Stevens and Miguez. You'll notice that it has two distinct halves. We're going to concentrate on the left half. Now, unlike the attack surface analysis, which concerns itself only with the establishment of boundaries that essentially form the attack surface, with threat modeling, we focus more on the actual vulnerabilities that data traversing the boundaries can yield. These issues are defects. So, what is a threat model? Fundamentally, it can be a representation of the system's data flows, its data stores, and its interactors. Alternately, it can be considered a collection of views of the system. Finally, it's an engineering design document. Let's consider the NIST Guide to Data-Centric Systems Threat Modeling and the 5 stages that it breaks up the threat modeling lifecycle into. The first of these is to diagram. This entails establishing what the system looks like in terms of the system's data flows. The second stage is that of identification. Here you take the diagram created in the first stage and apply a set of rules to identify deficiencies in the design. The third stage is that of investigation, where you determine what the fundamental issues are and how they should be corrected. The fourth stage is that of mitigation, where you go about the process of correcting the deficiencies. Finally, in the fifth stage, you validate that you've correctly mitigated the deficiencies. So now let's look within the context of the AVCDL and see how NIST's threat modeling lifecycle corresponds to processes within the AVCDL. If we take the diagram, identify, and investigate stages of the lifecycle, we can see that those map onto threat modeling in the design phase. Next, we have mitigate, and it corresponds to all the activities within the implementation phase because those processes all contribute to the mitigation of the deficiency. And finally, validation is mapped to the threat modeling review within the verification phase, where we confirm we've eliminated the deficiency. Here's the threat modeling process. Within the process, we undertake 3 individual activities: threat model creation, threat model analysis, and threat candidate triage. Let's examine each of these in turn. In the model creation activity, the development SME and the threat modeling SME take the system design documentation and create a threat model. Now let's consider a simple system and how a threat model for it might be realized. Here's a block view of a simple system. You'll note that this is not an automotive system, but it is a system that anyone can relate to. On the right, you have an interactor, an administrator who is interacting with the system via 2 modalities, the first being a web browser and the second a terminal. On the left, the system of interest, we have a web server and a console interface that the administrator is interacting with. Both are communicating with the core service. That core service and the terminal interface have both configuration and application data. We have multiple processes, we have read-write and read-only data stores, and we have different types of data flows. We can create a high-level data flow diagram from the block view. All entities within the block view have a one-to-one correspondence within the DFD realm at this level. We have 2 trust boundaries, one being between the core service, the web server, and the console interface, and the other between the web server browser pair and the console interface terminal pair. It's important to note that this is just the highest level DFD for the system. Much more detail is exposed during the modeling activity, but that's covered in the model creation procedure itself. In the model analysis activity, the elements threat model is taken by the threat modeling SME and analyzed with respect to the updated development requirements. Any identified deficiencies are put into a list of threat candidates. Analysis of the DFD is performed by considering each data flow crossing a trust boundary and determining whether any of the applicable cybersecurity requirements are violated. As a reminder, this is the resource access working model covered in the cybersecurity requirements material. We have a requester making a request to a resource owner to perform an operation on a resource. Any status and data are then returned to the requester. In some situations, the transaction may be subject to logging. Let's consider this from the standpoint of the data flows themselves. A request comes in, has a source, destination, and payload. There may be integrity checks. That payload represents a command with optional data. The command will either perform a write operation, in which case there's a value in, or a read operation. The result of the operation comes back as a write status or read data that goes into a payload, which forms a response. Finally, in red we see the cybersecurity properties and where controls would be applied. It's important to keep in mind that not all cybersecurity requirements, like controls, can be reasoned upon within the context of threat modeling. The final activity in the threat modeling workflow is that of triaging. The threat modeling and development SMEs review each of the threat candidates and determine whether they're valid. Non-applicable threat candidates are used to update the elements threat model to account for their use case. All valid threats form the list of triaged threat candidates. These will be fed into the standard threat ranking system. The threat ranking system is described in the threat prioritization plan material. A threat model report is generated, which tells us what the disposition of the threat modeling exercise is. Feedback is core to a cyclic implementation methodology and is the topic of the Understanding Cybersecurity Risk Freshness in an AVCDL Context elaboration document. As we can see, threat modeling in the design phase has feedback which channels through the threat prioritization process and eventually into the issue tracking system. This feedback can return to the element design review, also in the design phase, or to the element requirements review in the requirements phase. As mentioned earlier, we perform a threat modeling review in the verification phase to ensure that deficiencies identified by threat modeling in the design phase have been addressed. To illustrate how threat model verification fits into the vModel view, let's look at this diagram taken from the elaboration document entitled Understanding Verification and Validation in an AVCDL Context. It shows how particular artifacts created in earlier stages are verified in later stages. In this case, we can see that the threat modeling report created in the design phase is later reviewed in the verification phase. Additionally, you can see how particular downstream outputs, like threat modeling, rely on various upstream outputs from activities like design review. Since it occurs in the verification phase, feedback from the threat modeling review may have impact in additional places when compared with threat modeling itself. As we can see, the threat modeling review in the verification phase has feedback which channels through the threat prioritization process and eventually into the issue tracking system. This feedback can return to the element implementation in the implementation phase, the element design review in the design phase, or the element requirements review in the requirements phase. All AVCDL materials, both in source and distribution forms, are available on our GitHub site, as shown here. Because of the size of the repository, it's recommended that you either clone the repository or download a zip archive of it, if you're not familiar with using Git. Instructions for downloading a zip archive are linked to on the repository's front page. A set of training videos have been created to cover various aspects of the AVCDL that follow the training path found in the AVCDL primary document. It's important to note that all AVCDL materials, except for the introductory blog posts, are intended for product cybersecurity engineering practitioners. Once you've completed all the trainings related to threat modeling, you can proceed to one of the other trainings at this level. These are attack surface analysis, penetration testing, and vulnerability identification. Additionally, if you've completed secure coding and its prerequisites, you can also proceed to static analysis, dynamic analysis, fuzz testing, and secure code review. Here are the references to the source material used in the creation of this presentation. They'll also be included in the video description. Additionally, this presentation's source material will be provided on the AVCDL Git repository.